Hello. In this video I will detail the uRemote web server functionality. All uRemote couplers contain a web server. This is viewed on any standard browser. In this example I'll be using Google Chrome. First thing you need to do is type in the IP address of the device you want to connect to. So at the moment I'm physically connected to the device, and this is via Ethernet connection. Okay, it just takes a couple of seconds to load. There. So the way the system works is you physically have to build up your system, your island as I like to call it, which is the coupler and then the associated I/O modules. You build up your system, you apply power to it, and the coupler learns what module is in each location. So the coupler is in location 0, and then in this particular location I've got a 16 DOP in slot 1, 4 DOP in slot 2, etc. So you don't have to manually define the I/O modules, that is automatically done. What you do need to do is define some of the parameters in the modules. So I think I should start off by saying that before you can make any modifications you need to log into the remote system. So you go to this icon, login, and in my case I have the credentials saved in my Google Chrome browser, but if I didn't I would just manually type in admin, toggle down and tab down and type in detmold, which is capital D E T M O L D. Detmold is Weidmuller's hometown in Germany, so that's often used as a password. So then you click login. You are now logged in, close, and up here it says the only option is now to log out. Okay, so let's go through the web server stage by stage. So at the moment you can see an overview of the UR20 system. I can click into each module in turn to look at parameters. So if I click into the coupler, you'll see the type description of the coupler. This is actually an older version of a Modbus TCP coupler. The new version is a V2 and has some additional functionality. If I go and expand the parameters window, I can now see more information about the Fieldbus side. Obviously this is a Modbus TCP coupler, so parameters in here will not be the same as parameters for say a Profinet module or a Ethernet IP module. They're all subtly different. So at the top here I've got connected to Fieldbus on. So what that basically means is I am physically connected to a PLC. Okay, so that does mean that I will be unable to amend any parameters because I'm in the process of communicating to a PLC. It's never good practice to change the parameters of the coupler while you're still connected to a PLC. Okay, so as you can see I have my IP address configured as 192.168.0.109 as here. Okay, and then you have a subnet mask, and then you can have a gateway address if you want to connect to another network. My IP address is configured as static, as in it's all entered here, but I have various options. So if I click here you'll see you've got DHCP and BootP and DHCP and static. There are the 4 options available to you. So if you want to, you could use a DHCP or a BootP server running on a PC or possibly within a PLC configuration to assign IP addresses to this uRemote system. For simplicity I'm just using a static address. There are some other parameters here. I'm not going to go into them in great detail because this video is more related to the generic web server. What I should mention is the IP address of the USB port. If you're not familiar, USB ports use IP addresses in the same way as Ethernet ports use IP addresses. So with the USB port, we don't allow you to edit those totally. You have 5 options, an easier 5 USB port options. I generally leave it alone for simplicity, which basically means if I connect to a U-remote in the future and I can't remember the Ethernet IP address, I can always connect to it over USB using that as the default, and if that doesn't work through these consecutively until one of them connects. The USB port is here, which is service port X3 under a little flap door, and that is a micro USB, similar to what you would use on an old mobile phone. You've also got X1, X2, which are your standard RJ45 Ethernet connectors. On this device they act as an unmanaged switch, and they have one IP address and one MAC address. So it's just a way of bridging through to the next device in the chain. On the Mod V2, the main difference is those 2 Ethernet ports have independent IP addresses, independent MAC addresses, which means you can use them in a redundant system. Okay, so you've also got this feature here, web server via Ethernet, and it's enabled, which basically means I can view this web server through a browser over the Ethernet connection. If I disabled this, the only way of viewing the web server would be to connect via the USB port. So that arguably adds an extra layer of security. It means the only way to view and edit the island configuration is to be locally connected via a USB. So as you can see, there are quite a few parameters for the coupler. Then you've got an area called general information, and this is common to all the cards, and in here you'll find a serial number, the module type description, the hardware, firmware version, etc. and the MAC addresses associated. I&M area is basically installation and maintenance, where you can populate your own information, for example the location on the factory floor, the function of the device, packing machine, more of a descriptor, your name and date of installation. Just something that someone can refer to when they connect to it if they're unfamiliar, and it might guide them to whereabouts on the site the product actually is installed. Okay, so just to mention the LED status indicators. If I hover my mouse over each LED in turn, you get a tooltip that gives you a bit more information. So power LED means I've got 24 volt DC power present. SF is station in force mode. If that's on solid, if it's flashing, it's another problem. Sorry, if it's flashing, it's in force mode. If it's on solid, there's a configuration error. So you've got some guidance to what these LEDs mean. BF, bus fault. MT, maintenance, there's some error. LA1, X1 and X2 are basically activity on the Ethernet channels. So if you don't see activity on those Ethernet channels, it could well mean the PLC is not communicating or the cable is damaged. Notice here you also have 2 connectors. The top connector is supplying 24 volt DC for the 24 volt DC input modules. The lower connector is providing 24 volt DC for the output modules. They've been deliberately kept separate, so if you wish you could use a safety relay to feed the output module supply. Therefore, in the event of an emergency stop, for example, that 24 volt DC is removed from the output modules and all the outputs will go off. It's not the only way of achieving safety, but it's one method available to you. Right, if I wanted to change a module parameter, I just find a parameter I want to change, and let's say I wanted to change the Modbus timeout to 100 seconds. I can put 100, click out, and notice now I get this green icon. The green icon, whenever you see that, it basically means you've made a modification and you then need to apply the changes. So what I would then do is apply changes, or restore and leave alone. If I apply changes, I will get this message, and I'm getting this message because, as it says, the warning message is basically saying you can't apply any changes because you are connected to the controller, to the PLC or PAC. So I can't make any changes until I physically disconnect from the controller. But that is the process of changing any parameters. You click into the field, enter the value, you get the green icon, and you apply the changes. If you get that warning message, you must disconnect from the associated controller. It is important to realise that applying a parameter change does not save it permanently. It applies it only as long as you retain 24 volt power to the coupler. If you remove power, it will revert back to factory default. So what you must do, once you're happy you've totally configured your island and you've applied all the changes, you then go into this area, module parameters, and here you can save module parameters. So what this is telling me at the moment is there are stored values in the coupler currently because I have previously made a save. If I hit save module parameters, it would save the parameters, but the same comment as earlier, I can't do that because I'm physically connected to a field bus. But the key message here is you apply changes, then you go into module parameters and you save module parameters. If you don't do that, they'll be lost on power cycle. Obviously the default security is in the manual, so anyone can find that out. So the recommendation is you change the login. So here you can change the login, username and password, and there are advice on what type of characters you can use in that. I'm not going to do anything, so I'll leave that alone. Cancel. You can also reset the device to factory settings, straightforward, but I'm not going to do that either. Okay, so we've seen the coupler. Now we can move on to the next module. So if I click into this icon, I move right to module in location 1. So this is a UR20 16 DO P. DO is digital output and P means it's PNP switching rather than NPN switching. It's a solid state transistor output. Notice here you've got 16 pins or 16 connections for all of your channels. There's no 0 or 24 volt supply on this module, it's just 16 signals. There's no parameters, it's a very basic card, and being a digital card does not require any firmware, so there's no firmware mentioned. If I want to, I can click into here and this will open up a datasheet on the internet, and it's not actually the web page, it's just a datasheet, so you can look at information if you wish. If I go back to the U remote, okay, so that's a basic digital output card. If I click to the next module, I can now look at a 4 digital output. So this is again 4 digital output transistor PNP solid state 24 volt DC. General information tab as previous, and here I do have parameters. So if I click into channel 0, I have what you call a substitute value. A substitute value is also called a fallback value. So basically this means in the event of a loss of communications to the controlling PLC, what would you like to happen? Would you like the value to stay at 0, or would you like it to go high supplying 24 volt DC. This is application dependent. The default is always off, but you may have instances where you have a brake solenoid, for example, and you would want that to always come on in the event of a comms loss for safety reasons. So just to say, this is a 4-channel device, so all of those 4 channels have the same substitute value available. With regard to fallback or substitute values, there is another area you also need to configure. You need to configure an overall functionality of that in the coupler. So if I click back to channel 0, go to parameters, scroll down, and then here, output behavior on field bus error. This ties in with the output module's fallback values or substitute values. So if I click here, enable substitute values. So if I've put a substitute value of 1 on any of those digital outputs, I need to then go into the coupler and say enable substitute values. So this is a master enable or disable of fallback values for each individual module. So you either have it as off for all modules, enabled for all modules, or hold last value for all modules. Okay, so if I go back to that module and then we go to the next module. Okay, so we are now looking at a 4-channel digital input module, again PNP switching, and this is a free wire. So if you notice here, the white connection point is always a signal, red is always plus 24 volt DC, blue is always 0 volt DC common. These are actually commoned internally, so you can either pick them up individually or pick one up and feed it to all devices. It's your choice. The advantage of having a free wire connection, 3 points of connection, would mean if I had a 24 volt DC photoelectric sensor or an inductive proximity switch, I can run the free core multi-core cable directly from the sensor directly into this module without any intermediate terminals or any breaks in the connection. But this is your personal choice. You can either go for this style of card, or you can go for 16 channel card where it's just 16 signals and no 0 and 24 volt commons. Just flicking back to the digital output card, that is actually a 4-wire connection, although it doesn't say it unfortunately, but that again is signal, 0 volt DC, plus 24 volt DC, and functional ground. So again, if you had a solenoid or 4 solenoids, you could run a multi-core cable back to each solenoid without any intermediate termination points. So to my mind, the less intermediate connections, the more reliable the connection, the less likely a problem in the wiring. Okay, so we've looked at the first 3 modules. If we look at the 4th module now, this is a 4-channel digital input, positive switching, PNP, and again free wire. The difference with a digital input module is it doesn't have fallback states because you're not turning it on. It has filtering values. So each of these 4 channels will have the same feature, an input delay. An input delay you can also call a debounce time on certain loads. For example, a big contactor, when the electromagnet closes and the contacts pull in, the inertia, the contacts can actually bounce or bounce very quickly over a very short period of time, fractions of a second. And this can give false readings into the PLC. It thinks the output's gone open circuit again when it hasn't. So you use this filtering time. So if I applied 40 milliseconds here, basically that means the input has to be seen on for 40 milliseconds before it is seen as being on. Okay, so that configuration is available for all four channels. Okay, so if you look at the next module now, 16 digital input. So again, this is a very simplistic card. 16 connection points, no 0 or 24, PNP switching, 24 volt DC. Next module. So this is the most advanced module on this particular setup. So what I have here is my general information as usual, and notice here I have firmware because this is a more complex card. So there is firmware available for all analog modules, counter modules, PWMs, coupler cards, etc., and that is all available from our website. I'll detail that in a separate video. So if you look here, you have general parameters, so you can define the temperature range, because this particular module is for analog input RTD, resistive temperature devices. So these are all types of resistance probes, and the DIAG at the end means an advanced diagnostic version. Some of the cards don't have the DIAG at the end, which means they're slightly lower cost and they don't give you the same level of diagnostics. So I can define the temperature range, Fahrenheit, Celsius or Kelvin, and I can then configure each channel independently. So in this setup I'm using a PT100 probe. It uses a 4-wire connection and the conversion time is 80 milliseconds, and I do have some diagnostics enabled. Just to show you, if I click there, you can see that this is a multifunction temperature module, and you've got different types of PT probes, NI probes, CU probes, and different resistances, or disabled, which is how it would be initially. I've had to go in here and set this up. And you can also see that live data. I do physically have the probe connected, and I am reading back live data. So I am reading back 14.4 degrees. So I'm reading back the real value of the temperature. In this particular system, I don't have any standard analog input or outputs, but the analog input and output modules come in various channels, such as 4 and 8 channel, and they are all multifunctional. That is, they are voltage and current. They can be 0 to 10 volt, plus or minus 10 volt, 4 to 20 milliamp, 0 to 20 milliamp, etc. So that's all one module that covers various voltage and current ranges. Okay, so that's a look at all of the modules. If I want to jump straight to a module directly, I can go to this view, component list. So if I click there, I could then say click on that card, so it takes me straight there. So nice and simple, jump to a card or use these arrows to move back and forward a card position. So I have my overview, which you saw earlier. I have station data. In station data, I can see all the live data from all the modules in one screen, which is quite nice, quite powerful. So I can see all 5 modules. So the only thing in operation at the moment is a temperature probe. I've also got diagnostics data. It doesn't give a great deal of diagnostics in the browser, but a lot of diagnostics is available over the communications link. So at the moment, no diagnostics pending, everything's good. I've also got something called force mode. So if I click in here, force enable, you get this nice big red warning. So basically you should read that before starting force mode. But basically what you're doing now is you're taking control of the U-remote system, and you can turn outputs on. And in theory you could turn something on, you could turn a motor on, operate a solenoid, and cause some movement of the machine and either damage the machine, or more importantly, you could injure somebody. So be very wary of what you're doing in force mode. I'm going to start it because I know my system's safe. So now you get this red banner along the top which clearly shows you you're in force mode. You should never leave a U remote in force mode. You should always disable force mode when you're finished. So just to demonstrate what it's doing, well, firstly, if I look at the LED here, SF, station in force mode, red flashing. So that's also indicating that I'm in force mode, and obviously if I was physically in front of the hardware I would see that LED in that mode, the same as we're seeing in the browser. So what I can do is go to a channel on a digital output card, channel 0, and at the moment the value is 0. Click on it, notice the LED comes on, and if I go back to it, it says it's forced to a value 1, and it's highlighted its force by drawing a red outline around it. Also notice that this digital input has come on, and that is because on my system I have a physical wire between there and there. So when I turn the digital output on, it's reflected back as an input for feedback for my own diagnostic. And then to disable it, I just click on here and it goes off, and if you notice there's a slight delay before that LED goes off. This is all because we're using a browser. In a browser there is a slight time delay because of the update rate of the browser. So in real terms it would have changed state instantly, but on the browser it's a little bit slower happening. Okay, so I can force any of these. I could also force analog output modules, but unfortunately I don't have any analog outputs on this module to demonstrate that. I've got all green lights on here which shows everything is healthy. If I have a red light, there's a problem, and as I mentioned earlier, if I don't have a green light here, which means I don't have 24 volt supply in the output modules, then I will also have a red light on this module and this module, because they would not be receiving a 24 volt DC feed. I mean, UR20 is a modular system, but basically as each module clicks into the next, a bus is created carrying 0 and 24 volt for the input, a separate 2 connections carrying 0 and 24 volt for the outputs, and then your bus connection going along between all of them as well. Okay, so that's demonstrated force mode. I can now leave force mode here, disable, everything's back to default. Okay, so the next thing I should mention is the extras menu. So if I go to extras, I can save a service file. A service file is something you may be asked to create by Weidmuller technical support if you have an issue with your system, and it creates a file related to your island with some configuration information in. So if you go save service file, you can see it downloads it here, and it's a .wmi file. I don't think you'll be able to open that. It's not really of any use to you, but if you have a problem, please send that to Weidmuller technical support and we can use that to help diagnose the issue. Also in extras menu, you've got save load configuration. This is very useful if you have a lot of repeat systems. So let's say you're building 10 panels all with the same identical U remote setup in them. So what you would do is you'd configure your island as I've just demonstrated, and then once you're happy it's all working, you save, and that downloads it as a bin file on your PC. Okay, you can obviously go into that, open that file in your filing system and give it a more user-friendly name. As long as you keep the .bin extension, that's fine. And then you can go to the next island, connect to it as we are here. So you might want to connect to 0.110 and do a load, and a load will upload that same configuration into the new island or new system, as long as all the cards are identical. That's the presumption that every system is identical. The only thing left for you to change would be the IP addresses, because they would all need to be unique. Okay, so that's save and load. Then you've also got user defined tag names. So if I click in there, I can create a template. If I click on that, it downloads a template. I open it up, so it creates a CSV file, comma separated variable file. And if I just go in here, just to demonstrate it, where it says channel 0, if I call that motor, okay, so you could go for each one of them and give them a name, file, save. Okay, now I've saved it, I can close it, go back to here and go load, and go into downloads, and I load that file back. Sorry, it's not possible to do that because my system's live. But what it would then do is I could then go into each card, and in here, for example, it would have renamed channel 0 to motor. So that's something you can do if you want to. It's just an optional feature if you want to make use of it. Okay, so the next feature of the extras menu is Exchange TLS SSL certificate. A lot of modern systems today don't just rely on usernames and passwords as security. You also have a feature called certificate, and this would basically mean there would be a certificate on board my PC, and the same certificate would be on board the uRemote system, and I wouldn't be able to communicate between the two unless the certificate was valid. If I click on it on my controller, my uRemote, unfortunately I can't enable this feature because the coupler doesn't support it. This is an older coupler. If I was using the version 2, then it's possible. So the good news is I can't do it, but I'm told why I can't do it, and I've given a solution to why I can't do it. So that's quite helpful. So that's the extras menu, and then the next menu is firmware. So if I click here, as I stated previously, only certain modules have firmware. The coupler always have firmware, analog modules have firmware, but not digital modules. So I can go onto our website, find the firmware, click here, find the firmware, point to it, and then the same for all the other cards. I can either then update them one at a time, or ideally I do here click multi-update. This allows me to, as it says, update several firmwares on several modules in one go, so I can go away and move on to something else while the software is updating each module in turn. Okay, I can't do it because I haven't got anything to update. You've seen log out. The other option is language. So in language I can select English, German, and I think that's Chinese. And I believe, I've never tried it, there are other language files are available, so you can actually go on our website and download a different language file and upload that. So by changing the language, all you're actually doing, for example, if I change it to German, yeah, it's now all the menu system on the browser is all in German. And if I want it back in English, just click there. Okay, you can also access help, and all this does is give you a bit of information. So if I click here, it tells you what version of the web server you're using, where you can download a manual, and also an email address and a website. This is the international website. I've obviously Weidmuller. There's also weidmuller.co.uk. I think that's all the details I need to go over for the web server. I will be creating other videos that will go into detail on how you physically build up a UR20 system and where you would find the associated manuals. I hope you found this useful. See you again soon. Thank you.